minus the angle of the latitude. That's a simple formula, guys. We can observe this.
Okay. So when you take your measurement with the sextant, you initially take that from a flat or a level plane, yeah? And then you
I never use those devices. I have to look them up.
Then you will adjust your curvature, which could be the replacement of refraction.
No.
We can look up in the sky. We can look up somewhere that's. Oh no, we know. Yeah, of course, it's east and west.
I've done those. I've done those measurements once using a telescope.
But if you're honest, and we have to believe that we're both being honest. No one's trying to deceive anyone. I'm just asking questions. I'm not saying anything. I'm just asking questions.
No, you should.
And you have to conclude that the measurements taken from a sextant are initially just from a level. Because you've got you're pointing your sextant to your horizon.
Yes, you level it. Yes.
Which should be level. So that's
we level it.
Straight line.
And then we put that little thing. It's like putting your left hand or your right hand or whatever which you feel like. One hand flat facing the cup. I don't know how to describe this. Fuck it. And then your right hand, flap them together, and then put them level, and then like brace your hand a little up, to an angle. Yeah, we call that at an angle. Whatever. We level it. We can measure that angle.
Then you look in your book.
We don't need a book.
Huh?
Give it to a child. They'll figure it out. I bet you they'll figure it out. Don't even explain it. Let them. They'll naturally just ask them, what angle is this? And they'll use those tools naturally.
I did the book.
I did measurements like that in the late 80s when I was in the astronomy club, and I used the bubble level to set up my telescope, and we were on a tour, so we did 3 different measurements, and the distance between the furthest point is a tiny bit more than 900 kilometers in the north-south direction. And we got to rather close to 111 kilometers per degree over that distance. So you can even use a plumb line as a starting point to measure the angles. You don't have to use a sextant.
Plumb line.
Yeah, perpendicular to a plumb line. You have your like a protractor. You know how a protractor works.
I never used these devices, but is that an object that falls directly to the direction of the straight down?
Yeah.
Okay.
So you just use it, and you use that as your baseline for measuring the angles.
Yeah, it's level right there.
Yeah. So,
to use a protractor though, you're assuming that you're on a globe straight away, yeah?
No, I did this. You can do this on land. You don't have to be on a boat. You can do the same measurements on land.
Oh yeah, but what I mean to say is, just using the protractor, you're assuming that we're on the Earth, because like a protractor is 180 degrees.
Where else would you use it?
No. If you have a plumb line as a baseline, you can use that plumb line to measure angles to the stars. You agree with that?
But we're not talking about the Earth yet.
You imagine if you was on a windy day, you'd have troubles though, sure.
Yeah, but then you don't use it, then you use something else. Come on. Then you use like a spirit level or a bubble level or whatever.
Would you use the spirit level because they're curving? You wouldn't get a plumb line, would you?
Look, there are many
Probably
geniuses
do.
who invented these two devices to measure these things, to measure the angles, to measure
Yeah,
like the speed
you
of the
use the
angle.
plumb line, you're going to be
There's amazing telescopes out there that I saw in the astronomy club, and we saw these, and I saw these things too. I don't know how they use it. I should have device, but I never did.
I
But
see that myself. I've
they
seen
use these
some
things.
amazing ones. Some kid had one in the garden set up, and he was showing some pictures, and they was amazing.
Yeah, we can get the angle. We don't have to supersede anything. We can get the angle.
I was looking at the depth of the pictures, you know, like and how they appeared, and yeah, very cool.
Yep. Anyways, let me copy and paste this. All right. So the angle is this formula right here. Let's see if this. Oh, for fuck's sakes, that didn't work. Let me delete that. Oh crap.
Were you posting it in the live chat? Yeah,
Ooh, I found a way. Okay.
live stream.
So yeah, so the latitude angle equals the 90 degrees
Hold on, what's it?
minus theta. There you go. There's the beautiful formula right there you can use. All right, so using that formula, if you measure the Polaris around like this angle, it should be close enough to be 30 degrees. At what angle does the star rise and set? If the latitude of Polaris is 30 degrees. So if the latitude angle, no, if the angle that at which the star rises in the east sets at the west is L, and theta being the observer's latitude angle, and the latitude angle is 30 degrees, 90 minus that angle, what is, so if the latitude angle is 30 degrees, what is the angle that the star rises and sets?
Like the altitude angle or the azimuth?
The latitude and the star rising and set angle. I don't know what you call that, but
Well, stars always rise and set at like 0 degrees because that's where the horizon is.
they're gonna rise at some. Just look in the chat.
I have been. What's like? Are you talking about like its elevation angle?
You know what an angle is?
Well, yeah, but there's different types of angles in astronomy. I'm just asking which one you're talking about.
Right here. The angle at which the stars in the east and west rise and set relative to the horizon.
Well,
I mean,
yeah,
what more specific do you want?
yeah, stars always rise from wherever the horizon is. So the
Yes,
angle it rises.
the definition of rising and setting is when it reaches the zero.
Yeah. So it really just depends on your surroundings. Like if you're in the open ocean,
Look at the east, you find the angle at which star rising relative to the ground.
yeah, which would be like 0.
No.
What do you mean? If the horizon,
That's like saying that the sun rises like, I don't know, straight over the horizon, or maybe 90 degrees, depending on which you define zero. But
Then you're
that doesn't make
talking
sense.
azimuth angle.
I'm very
yeah,
confused right now.
like okay, so are you talking about like so you're saying since
Is he talking about
the
Estes?
star so I think I got it. So like when the
Can you
star
type in the
rises,
chat?
the star doesn't rise directly upward from the east. It goes up and then maybe a little bit to the north or a little bit to the south, something like that.
There is a bit of refraction there.
Well, it's just you say angle, but there's a million types of angles in astronomy. There's altitude, there's azimuth, there's right ascension, declination.
Which angle do you think I'm talking about? That formula that I gave. I defined those variables for you.
But when you said star rise and star set, that describes an elevation angle relative to the horizon, 90 degrees from vertical. That's zero. By
Yeah.
definition, even if it rises in the southwest, no matter where you are, it
Okay, look at
rises
that.
at
Okay, Genius says, look at the formula that I gave to you guys.
Yeah, 90
yeah,
minus theta.
Yeah, interpret that in your mind. If you're taking my words
yeah.
too literal, then I don't know what to
Well,
tell you.
okay, so let
It
me
means that you
try
can
and
interpret
explain
things
this.
very well.
So in astronomy,
Yeah, you're gonna
um,
just repeat what you said. I heard that.
I know I want to understand what you're asking though, because in astronomy you have altitude
Look at
and
the chat.
azimuth angle. So when you're asking what angle does the star rise at, are you saying what angle relative to my horizontal, or like relative to like what angle vertically in my field of view does it rise from?
And go vertically. What the fuck does that even mean?
I'm trying to just understand what your question is.
What was the equation again? L equals 90
90
minus,
degrees minus the latitude angle.
and what was the latitude angle? 0.
No, well,
Because you have it like L equals
not
90
not.
minus 0.
I mean, not if you live in the equator, I guess, but you can go a little up in latitude.
You're talking about
You
like
can
a
measure that.
diagonal angle, right?
The latitude angle to Polaris.
Yeah, but the equation looks like you're describing, if you're at 45 degrees latitude, then the stars kind of set at a 45-degree angle. Is that what you mean?
Yeah, exactly.
Okay.
There we go. Yeah, you can help me interpret that angle. That was all. You don't need to take my words literal to interpret that. You know what I said there. And it wasn't even me; it was the AI saying that.
All right. Let me post a picture real quick. See if I have. I think I get what you're asking.
Oh my god! Please, holy shit!
So it's like as the
Yeah.
star rises, it doesn't rise perfectly vertical.
Okay, from the horizontal, not from the vertical. Measuring counter or clockwise down or counterclockwise, depending. But from the horizontal or counterclockwise.
Did you say the
That angle.
star's moving or we're moving?
Yes. Okay. Well, thank you for posting the image. But
It
yeah,
like
that horse.
is
So are we moving or the star moving?
the Earth is spinning, which causes the stars to look like they're moving.
Oh, so the
But
star's just sitting still
yeah,
and we're moving.
yes,
Like
technically, but it's
well,
much
what I
easier to refer to it as the star moving.
well, what I said earlier, or whoever the other guy was, is look at the variables of the equation. L equals 90 degrees minus theta.
Well, I'm only
So you can
jumping in.
so you can interpret that angle being that. Oh, actually, wait, I'm an idiot.
Like I'm only jumping in halfway through here, so I don't have the full context.
I had to
Of,
visually see this to correct myself. I apologize, guys. I meant the angle for vertically. My bad.
Vertically. The zenith
Yeah.
angle. Or just
Yeah,
the
I
vertical.
apologize. I just sounded like an idiot. So I got my visual
well,
image all fucked up. But I got it.
yeah,
But
the vertical angle. All stars rise from a
we,
vertical angle of about 0 degrees.
so you're not talking about directly above you. You're talking.
Vertical angle? What do you mean vertical angle as a grid? That doesn't make any fucking sense, to be honest.
Like, okay, so if zenith is 90 degrees.
Yeah.
The horizon is at 0 degrees.
Uh-huh.
Since
Then
all
the angle
stars
that you're looking
since
at.
all stars rise from above the horizon, when it
Angle
starts
rising
to
at 0
rise,
degrees. What the fuck does that even mean? To be honest.
okay, do you know what zenith is?
Yeah.
Okay. Now, if you imagine a giant sphere around you, you can look all around you 360 degrees in a sphere. So directly up is 90 degrees,
Uh-huh.
directly forward, not tilting your head up, not tilting your head down, but directly forward is 0 degrees, and
That's
looking straight down is negative 90 degrees.
so that would be 90 degrees. So say like your zenith is straight above you, and then to
Yep.
the horizon, that would be a 90-degree angle. Or, you assume it's a 90
Yeah.
degree angle.
So yeah,
And
the
vertical,
horizon and zenith form a 90-degree angle,
so you're
but the horizon is always measured at an altitude angle of 0, and zenith is always measured at 90.
so then your vertical angle would be anything in between the zenith and the horizon, yeah?
Exactly.
Okay,
And
we've got
so yeah, and because the star rises from the horizon, by definition of rising, it always starts out at 0 degrees, perfectly horizontal to you.
Your diagram before Seafoam. That's what he's talking about. That angle.
Okay, I thought so, but I didn't get like a good confirmation of that.
All right.
Okay.
I want to ask an honest question. Am I making myself unclear? Like, what the fuck is this?
It's not that you're making yourself unclear. It's just I joined halfway through and I'm trying to get the context of what the conversation was about.
I posted in the chat. Read the
Well,
chat.
well, okay. All you posted in the chat was um,
Yeah,
theta
read
being
it.
the observer's latitude.
Yes. And what's L?
But
latitude.
but like, what's L in reference to what? Where's the letter L
The
coming
angle in
from?
which the stars in the east, west rise and set relative to the horizon.
Right, and that's the red angle you're talking about in the picture I posted.
Yes.
There's no
Okay,
such
all right.
thing as a red angle. That's a straight line. The angle is from wherever you point towards. It's the fucking measurement between the circle measurements between two rays or two lines or whatever
Well,
that's the
Yeah. So
definition
yeah.
of a angle.
one ray
If
is
it's
the
right.
path of that star, and one ray is the horizon. Right.
So who posted the red laser
Yeah.
beam
Okay. So that
with dots on it?
that's dependent on your latitude and also the right ascension and declination of the star. So you have to choose what specific star you want to talk about, because if it's one of the circumpolar stars, like let's say we live at 45 degrees latitude north, that means that a star at 45 degrees declination is gonna just barely touch the horizon and then slide along it tangentially.
We have amazing technologies that we can take film images of the stars. Just
Yeah.
put those images just like the screen you have there, post it in the chat with the ray laser beam. Like follow those trails. See that trail? Look
Yeah.
at the
So
angle right there. Like I can use if I had a protractor, which I have some here somewhere.
let's
I
see.
can measure that angle. I can measure that angle in the screen.
That angle is 28 degrees.
Okay. You said 28 degrees.
Yeah, 27, 28, somewhere in between there.
All right. Just to get the right angle.
Yeah.
Oh my
What's the
god.
degree? It's only 60 miles.
Yeah. It just depends on the right ascension and declination of the well, I guess really only the declination.
Yeah, he's only talking about looking east-west.
Yeah, okay.
Thank you. Actually, thank you, whoever said that.
So
Yeah.
so like a star.
This is way more confusing than it needs to be.
So a star rising.
I just posted in the fucking chat, right? Like L represents the angle at which the stars rise in the east and west relative to the horizon. What more clear do you want?
Stop getting so angry.
I'm just trying to get an understanding. Like I don't know why you're so offended by me asking questions.
Because it's in the chat. I'm not offended. It's just like I'm annoyed
Yes,
right
I
now.
know it's in the chat, but I didn't hear what you were saying in VC. That's the thing. So in the chat, all I see is, "Hi guys, I'm new to the server. Theta being observer's latitude. L represents the angle. L equals 90 degrees
No,
minus
no, 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 no,
theta."
no, no, no. Wait. What did I say?
You
L
said,
represent the angle. I think I posted there
"At
many
which the
times.
stars east to west rising and setting over
There
the
we
horizon
go.
and 90 degrees."
Well, I might have mistyped there, but I meant to say L being the. I don't always correct my grammar here, but L represents the angle at which the stars in the east, west rise and sets relative to the horizon. I said that.
Okay. So that, I guess, yeah, that just depends on your latitude.
Yes, it does. Of
It's a
course it
good globe
does.
proof, by the way.
Thank
I
you.
like it as a globe proof.
Oh my god, I felt like I was the only person in here.
I thought you were
I
asking
swear to
a
God, I was
much,
thinking that a lot of Gloversers didn't understand
no,
what I'm
I thought
saying
you
or
were
something.
asking a much more complicated than you were.
No, it's not. We can
Yeah,
measure these
okay.
things.
So yes, you have it right that that angle right there, directly east and west, is 90 minus your latitude.
Yes. Somebody posted.
Schuber.
Yeah. So yeah, Shoebill, he's saying that as that star rises, it's rising at a 27-degree angle. So the red line is at 27 degrees,
And
which
and
means
and here's a nice thing too is that if you look at that image, the rising image in the vertical angle, you can just like point right there. You can just draw a little point and 2 points and make the connection where the angle to Polaris is. It's like right at 90 degrees of that line. So you can draw a yellow line and you could put it 90 degrees.
yeah.
Amazing. That's Polaris right there. That's the angle to Polaris. We can
Well,
visually see this.
to the north celestial pole. If you
Yeah,
want to
to
be
the north,
really,
to the north
if you want to be
celestial
really
pole.
pedantic about it.
So Polaris is in the middle.
No, no,
No,
no.
Polaris.
He's saying if you draw a line perpendicular to that red line, it'll go to the north celestial pole.
There we go.
Yep.
It'll lead
Oh
you
yeah.
there.
Okay.
Oh, thank God we finally got this. Okay, good.
Oh, fuck! It sounds way
I
more
thought you
complicated
were
than it is.
asking a question that was much more involved than it really was.
But if we're moving in multiple directions, if we're moving in multiple directions, or are we just on one path, on one sort of trajectory?
Well,
No, he was saying like, so
there's
if a
different
star,
latitudes. Oh, go ahead.
yeah, he was saying that if you look at a star that's rising due east, so 270 degrees azimuth exactly,
Mm-hmm.
the angle that it'll traverse through the sky. So as it rises, if you measure it like as it rises and then 1 minute later and draw that angle, the angle
Yeah,
that it traces there is 90 minus your latitude.
I get that, but what I don't get, are we moving as well?
Well, yeah, the Earth is the thing that's spinning that's causing the star to look like it's moving across the sky.
Yeah, but are we going in several directions or just one direction?
Well, all the vectors add up, so you're really only going in one direction at a time.
What's a vector, Schlitzy?
What's a vector?
Yes.
Oh, yeah.
I knew Seafoam would say that, and I was like, way over Schlitzy's head.
Well, yeah, but
Why
basically,
would you say that?
but
How
I
about we
mean,
phrase it? Can I phrase it differently? If you're on a plane flying at 900 kilometers an hour forwards, and you walk from the left of the plane to the right of the plane, are you moving in two different directions according to you?
Go on, say that again.
If I'm flying on a plane, right,
Yeah, you're on a plane.
and I'm flying at 900 k's an hour, if I walk from the left seat to the right seat, am I moving in two different directions according to
No,
you?
you're in a controlled environment. So the plane is moving. It doesn't matter how you're moving because you're moving inside the plane. So
well, he's saying like,
that has no bearing on anything. So like what you're talking doesn't really make any sense.
well, he's saying
So
like,
you can't answer
if
the
you're
question.
if you're on a plane, like you're on a really cool plane that has a glass bottom,
Yeah, but you can be
and
on right.
yeah,
I get
so
it.
you're on a really cool plane that has a glass bottom, and your friend with binoculars is looking up at the plane as you walk from the left to the right.
Okay.
He's gonna see you making one singular line. It's not like you're going two directions at once. Relative to the ground, if you're on a plane going 900 kilometers an hour and you walk from the left to the right, you're gonna still walk in a straight line relative to the ground.
So what reference frame would that be then?
Relative to the ground.
Relative to the ground. But it doesn't. Right. Look, you're in a plane and you're flying from east to west, or you're just flying. Like you're on the flight path and you're going from A to B. Let's
You're
put
just
it.
flying in general in
Yeah,
one direction.
you're flying in general, and you walk from one end to the plane. It has no bearing on what the plane is doing. So I don't get. I don't get. You know,
Okay. Let
it's a
me
nice
draw a
concept.
picture.
Nice concept, but it doesn't prove anything. It just
We're,
means
we're
that
just
you got
asking.
out of your seat and you walk from the back of the plane to the front of the plane. It's
We're asking whether
not.
you think
You're
these
the one.
two motions
Yeah,
can
it's
be sort of
too much.
combined into one.
Okay,
Yeah.
yeah, but that's not really the same depiction of what's happening in being inert,
No.
hurtling through space, and they're two separate things. They're not within each other.
We're just trying to get you to a place where we can have a conversation. We need you to understand that you can combine two motions or two vectors into one.
Yeah, but that's a bad analogy because that doesn't make any right. Look,
Don't
I
worry
get
about
what
whether
you're
it's a
saying.
bad
I
analogy.
understand. I understand fully what you're saying, but
That's not an analogy.
well, you're moving within something that's moving.
Yes. So there are
Yeah.
two movements, right?
Yes, but it doesn't have any bearing. You could be jumping up and down. You could be jumping up and
Right.
down, doing jumping jacks. It
But
has no
someone on the
bearing on
ground,
playing
like
proceed.
Steve Holmes said, if someone's on the ground and then can somehow see through the plane, what do they see your movement as? If you're walking from the left of the plane to the right of the plane.
They see the plane moving, and
Yep.
that's the most important thing. Don't take your mind off the
Oh,
plane moving.
Jesus.
Here,
And they see
look
someone
at
moving
the
inside the plane, but it doesn't have any bearing on the plane moving.
look at the
Oh,
picture I
fucking God.
posted. Look at the picture I
Oh,
posted.
oh
So
God!
the yellow dot over time is moving from the right side of the plane to the left side of the plane.
Let me have a
While
look.
at the same time the plane is moving forward a lot faster than the guy. So even though the guy's moving perpendicular to the direction of the plane, if you're on the ground looking up through the plane, you see the guy traveling in the perfectly straight line of the red line that's just angled slightly from the direction of the plane itself.
So do you understand and therefore are capable of having this conversation?
Right, look. What would convince me is the plane
Fuck.
going
We're
along.
asking, we're trying to get to a
No,
point where we can have a conversation
look,
with you,
you're
but you
understanding.
keep arguing.
I'm not arguing. Look, I'm trying to get my head around what you're saying. So look, let me say this, yeah? I can understand better if you show me the picture of the plane and the guy was spinning around the outside of the plane. That I can understand.
All right,
Can you
I'm
see
face palming
Seafoam's
so hard
picture?
right now. I don't know what to
Yeah,
say.
Seafoam's picture. That red line is what the observer on the ground sees the person doing. The person is walking from the left of the side of the plane to the right side of the plane. All right, can you see that red line is not a straight line with the plane's travel
So where would you be observing that? From the Earth?
Yeah,
from
the
the
ground.
ground? Yeah.
It's a
Do
glass
you?
bottom plane.
I think you'd struggle to see someone moving.
Oh, for fuck's sake.
Okay, I said he has really cool binoculars.
It's
Okay,
been a good talk.
Yeah, fuck.
what kind of
You
binoculars?
do wonder.
Okay, the make and model of binoculars doesn't matter.
Just good ones.
Yeah.
Okay,
Anyway,
here.
I'm gonna
You
go
know
and
what?
feed some dogs.
I'm gonna
Yeah.
screen share something. I hope I can screen share here.
Okay.
Okay.
Don't tell
So
me
we're
you've
in
got someone
Blender. Okay. So
really cool.
here's our plane,
Pardon,
and
I don't see you.
it should be doing a screen share.
Oh yeah, live streams.
Oh, is it not? Am I in the wrong?
Yeah, I think you're in the wrong one.
Is it?
Oh my god.
I
Did
don't
I
know what other
join?
arguments to give, to be honest.
Oh, okay. I wasn't in the VC with my computer account. There we go. Now you should see it.
I've never been so
See it.
engaged in this conversation before. Holy shit. Wait, somebody on Blender? Or what's going on?
Yeah. Okay. Watch this. So here, this box is our plane.
You don't want to be in a blender.
So from time 1 to 100, the plane moves, right?
It's going up. It's a rocket.
No, this is from the
I've got you. Now you changed it.
yeah. This is just a top view, right? So the plane is moving.
It's got no wings.
I can add wings if you really need them.
Yeah, then I know which way it's going. Well, depending on which time or reference frame I'm looking at. Ooh,
There we go. There's the wings.
that's super cool.
So this is our super cool, awesome plane.
I'm guessing it's not very aerodynamic.
No, it's not. All right. So let's say this sphere is you, and you're sitting here on the left seat, right?
Then my favourite seat above the wing.
Yeah, you're in your favorite seat. So what I can do is I think, or Control P. No, I did it backwards. I always do that backwards.
I'm feeling a bit seasick now.
Okay, so yeah, so you're on the plane. No matter where the plane moves, you're moving with it. So as the
Okay.
plane moves forward, you move forward. Right?
Because I'm fixed.
Yeah. But what would happen if so from here we can do that. But then what if at the end you saw your friend over at the right side here and you wanted to go over here with him? So what would your motion look like now? If we play it out, you see how he's going always perpendicular with the plane, right?
Yeah. But that has no bearing on the plane's flight path.
We never said it did.
Yeah, but what I was suggesting is if we're spinning at 1,000 miles an hour but also traveling forward. That's not within anything. It's like two different,
No,
two different
I think
motions.
Well, okay.
I think
Are
your problem is understanding what is meant by whacked. I can give you another example. As we fly,
I understand. I understand that.
helicopters in the North Sea, and we have a side wind as the helicopter's going on shore. The helicopter, the path of the helicopter, or the angle of the helicopter, up against the wind. So if there was no wind, we would not hit the target. But the wind is moving us sideways at the same time. When you plot that out, you end up with one straight line.
Yeah, look at this. So
Are
even though
you
the guy
flying the helicopter?
even though the guy is moving perpendicular to the direction of the plane, as I play it, he's always moving in a singular direction. That's not two directions at once. They add up, and he's moving in a singular direction along the orange line.
I can see why they would add up. Just looking at that, I can see why they would add up linearly and make that straight line.
See what?
Because the plane would have to be moving at a constant speed for that to be a straight line.
I understand your concept, but what I don't understand.
Under a scrape.
Yeah, the screen thing is absolutely fine. I get it. But what I don't understand is the so-called, we're spinning 1,000 miles an hour, and we're traveling through space, and other things are moving as well. So there's all different things. This is what I don't understand. So, I go on a train.
Well, we
I
can
can
explore
jump up
that.
and
We can start simple.
I can
Well,
jump
yeah.
up. I don't smash into the wall because the train's going along, because I'm contained in a space and I'm traveling with that motion.
Are you asking like why the stars don't appear to shift?
I think he's asking
A
why don't
lot.
you appear to move if the
Why
Earth
don't
is moving that fast
stars, if
or something like
we're
that?
going in all these different kind of crazy directions, why don't the stars represent the crazy direction? Because if we're spinning and we're spinning this way and we're flying through, different ways, how comes we don't see the stars go crazy things where they're just spinning around in a circle? That suggests to me
That's a good question.
that
So
suggests to me that we're not moving, and the stuff in the sky
But
is
here's the thing: the stars
let's think
are
about it.
far away.
Yeah,
They're very
that's what I was
far
gonna
away.
say.
They wouldn't move.
How do you know they're very far away? How? Because they're
Well,
just lights in the sky.
because actually,
And we can observe the movements.
the
That's why
motion of the Earth, because we know how large Earth's orbit is, and
How?
for some of the closer.
Yeah, but let me add something. Like we know the pathway that the Earth's orbit. We can visualize the pathway. We can visualize the Earth going around the sun, right? That circular plano pathway, that oblique or that near circle pathway right there, the area that fills that void. Compare that to the stars.
Yeah,
If the
but when
stars is really far away,
we
they would
know.
move circular around that pathway, but they wouldn't move much.
Yeah, but you say we know.
So we wouldn't be
When
able
I
to
don't.
compare
When
you
I
detect
don't
anything.
know.
Unless it's an exoplanet, which we can, but and
I
we
mean,
can maybe determine how far it is depending on the position that we are.
like I
So
personally don't know exactly how they got the measurements, so I can't tell you how they got the measurements. But
That's
but
what I
they're far
will
exactly
away.
say
right.
is
So it's a.
because the stars are far away,
Mhm.
We barely
our motion, like to scale, our motion is minuscule. So
yeah.
like basically imagine it like this. Imagine you're looking at a mountain way in the distance.
Uh-huh.
Way far in the distance, right?
Yeah.
And what if you shifted your head like 2 centimeters to the left, 2 centimeters to the right? Is the mountain going to shift in your field of view by any meaningful amount? If you shift your head 2 centimeters to the left, then 2 centimeters to the right.
It's like your eye is going to be fixed on what you're looking at. So I would imagine you would sense you're just
brother.
it just shifts from one, like from one to the other, like concentration of your eye.
Okay, well, let's say we have some even farther, like a star behind the mountain, right?
Oh,
You shift your head, you shift your head left, you shift your head right. The mountain, even if you don't tilt your head, the mountain is still going to appear pretty much directly in front of you, right? Because shifting
Okay.
your head 2 centimeters
So if you
isn't
close
going to.
one eye, if you wink, and then you wink with the other eye.
the stars would remain relatively fixed
Yeah.
on the sky.
I'm guessing the star
You
wouldn't move,
barely would
even
see
though it
any
would appear to move.
No,
But
motion.
we're talking about the mountain though too. If you wink your eyes, but you're looking at a mountain really far away, I don't know.
it shifts from left to right. So if you right, look at something right now, and close your right eye, and you'll only see with your left eye, and you will see to the left of what you're looking at. Your peripheral becomes your, say like when we're looking straight ahead with both eyes open, then you close your right eye, your peripheral vision will be more, apparently what you're looking at. And then when you close your left eye, it will shift over to the right.
Right, but
Parallax.
if you think
We can do that.
about
We can do that right now.
the angles, if you think about
Yeah,
the
but that is
angles real quick, so a mountain far in the distance is going to be miles and miles away. Okay, if you move your head side to side 2 centimeters,
Uh-huh.
the mountain is not going to move in your field of view. It's going to stay exactly where it was, and one side of your motion, and exactly where it was the other side of the motion, right? Because 2 centimeters compared to a mountain miles and miles away is not a lot of distance, right? So there's a really small angle that's changing.
Hold on, let me get this right. So I'm looking at a mountain in the distance,
Yep.
and I move my head to the left 2
I've been
centimeters,
talking about this.
and I move
Yes.
my head to 2 centimeters to the other side, and the mountain doesn't move. Yeah, it's like your eyes are like gyroscopes.
Well, like maybe if we did a camera, right? If you put a camera
No,
on a
I'm doing it
tripod,
right now. I can see a mountain in the distance, and I'm looking, and it's like your eyes are they're like gyroscopes.
right?
Nothing moves. Yeah, you're right. You're correct.
Originally, you
Exactly.
were asking
So
why don't we go all over the place? I don't even understand
yeah, so in the
what's going
grand
on
scheme of
anymore.
things, when you think about the stars that are really far away, Earth's
But
orbit
how do you
around.
know they're really far away? And
I
they're just
can't. I
lying in
can't.
the sky.
Yeah, I
I
can give you a
can't.
few. I can give a few ways how the stars are measured. Parallax is one. Three-third
Parallax.
stars.
What's parallax?
Well, yeah, but then the
Standard count. Just
parallax.
parallax is exactly what you did when you closed first one eye and then the other.
Mhm.
That's yeah. And
Yeah.
then you
So.
have Cepheid variables, and you have standard candle.
You have to
And
be
on the long
pretty
distances,
measuring
they
things.
use redshift.
So what parallax basically is, if you take a really detailed measurement of a star, and then you take a similarly detailed measurement to the star 6 months later, the star will have actually shifted its position just a little bit,
Just a tiny bit. Yeah,
just a tiny itty bitty little bit.
yeah.
But that only works for like the closest stars, right? But
I think it's up to what is it? Is
I
it
think that would
100
work
light
for.
years?
I think that would work for any stars, but yeah, the closest stars, because
well, yeah, but
the
as they.
change would be very tiny, like 2-0.
Mhm.
Oh,
So it's pretty hard to
stars.
detect them.
Yeah, but basically, to get to the point, the reason why the stars aren't moving like crazy is because the Earth's
Far away.
orbit, the Earth's orbit relative to the distances to those stars, is exactly like looking at a mountain and then moving your head 1 millimeter to the side. There's
See, I'm
not going to be
confused again.
much.
I'm confused again because you said the stars don't move and then we move. Now you're telling me the stars do move. even
Of
though we
course we
move as
move,
well.
but you wouldn't detect emotion, any movement on the stars. It would
Yeah,
just be a tiny
But
change because
you
the
just told me.
star
You just
is
told me that.
far away.
But
yeah.
you
Because
just
it's far
told me.
The
away,
stars.
the farther away it is, the less the movement you detect.
Yeah, but
And the
you
stars are
just
moving.
because I'm
Yes,
The
but you
asking
don't
a
know
stars are
that
The
they're
moving
question.
alive.
with
stars.
us. Yeah, the
Yeah,
stars
the
are moving
stars.
with
Yes, it
us,
is.
But
Yeah,
the distance to them uh, uh, make it seems like they're not moving, but in fact
yeah.
they are. Yeah,
If
and
it like
even the different stars change position between one another,
No, I'm trying
as
to
has
get.
also been measured.
like I've done it before where I took one of my pictures of the Orion Nebula and I overlaid it on a picture from 100 years ago.
Mhm.
And over those 100 years, some of the stars have noticeably shifted their position. So no one's claiming that the stars are perfectly fixed. Stars are not
Yep.
perfectly
Hold on.
fixed.
So
You also
you're
know that,
telling me.
there's a lot of exoplanets out there that
So,
changes.
so
So
hold on.
it
You're
cannot be
telling
stars. It
me.
might not be stars though.
You're telling me that you had a photograph of the nebula 100 years ago, and you took a
Yeah.
picture with your telescope 100 years later, and there was a shift.
Yeah. Some of the stars have a very noticeable difference in position.
So you're telling me in 100 years worth of technology, you must have a shit telescope.
No, I have
You
a
heard
great
It
about
was
this
only
guy.
telescope.
some.
Yeah.
I'm saying
It was only
like
some of the stars that had
Oh,
moved in relative
yeah,
in relation because yeah, he laid the two photos on top of each other, and you could definitely see the how
like
they
four,
lined
four or
up,
five.
and many of the stars, were absolutely like machine drilled into it, and there was several stars that were in slightly different positions over the course of
Yeah.
100 years.
do you think that could be the 100-year technology where your telescope was more focused and the other one
Well,
was
No,
sort of out of
no,
no,
focus?
because
It was a high
the
quality. It was a very high quality photo from
I
100 years
can
ago.
am I still screen sharing? I don't even know if I
What
am.
and,
Yeah.
was
and
photographed
I remember
100 years ago?
they're still measuring this today with much more accurate equipment as well, and you don't have to wait
They should,
100 years.
Yeah.
they should get that. What's that Japanese
Yeah. I let
telescope
me
to
let me
take the
let me
picture?
work on I'll do it again. I'll overlay the two pictures and then I'll get the screen share
Okay.
once I have that done. It should be
It's amazing though. Like they took a picture 100 years ago, then you took a picture 100 years later, but you've still got the same technology in the telescopes. I'm amazed.
Well,
Yeah,
film photography was very high quality even 100 years ago, and now we
well,
use digital or film, and they return the same results.
Yeah,
well yeah.
you've only got to
Film
look at that Leica, the Leica camera, the M35. It's fucking still a couple of £1,000.
Yeah. So imagine a big university telescope with film plates 100 years ago at the highest level of technology of 100 years ago.
Where
And
was that telescope?
well, I'm sure he could find the observatory that supplied it. But as you know, there are many dozens of major observatories in the world
Yeah,
of
I just
equal
wondered.
quality.
No, what I was going to say to you, if he took a picture, wouldn't you have to be in the same place as the original picture to overlay that picture to represent that variation in
It
position of
goes
the
back.
star?
It goes. It
no,
yeah,
goes back to
the
what we.
stars the
It goes
stars
no,
back
that
to what we're
because
saying. No, it goes back
because
to
that
what we're
was
saying. It's going
yeah.
back to what we were saying a minute ago. Is that if you're a couple of thousand miles apart on the Earth,
It's
that's
nothing.
insignificant.
yeah.
Yeah. Listen to
It
this, right? Listen to this. I'm going to shoot a gun, and I've got you in my sights, but I'm a couple of thousand miles away. I'm not going to kill you.
To shoot a guard in the country. Okay.
So
And what does that have to do with photography?
no, it has to do with that difference in that little minute difference does make a difference, because say that you're going
But
to
I'd
kill
love
me.
Solarium. I kind of want to.
I'm going to kill you, but you're going
That'd
to
be
kill
fun.
me, and I shoot you, and I'm 2,000 miles away from, but you're going to kill me. So it does make a difference.
So let me ask you a question then. If the change of the position of the stars were due to your position, that you don't have the exact same position, then shouldn't all the stars have moved in the same way?
Say that again.
Remember,
Get my head around that.
what is measured there is the angular separation between the stars changing.
You didn't say that.
So
You said that.
If you just change position on Earth, then all stars should move in the same way. They don't.
Well, I thought all the stars moved around the main star Polaris in the north.
The individual stars we see on the sky also
wandering
moves.
stars. The ones they call wandering.
No, not the planets, the stars. As was shown there, this is the Gaia mission measured, what was it, 1.7 million stars, and how they move independently of one another. At the same time, they are rotating with the galaxy.
Okay, so do they rotate, but they're also moving as well?
The galaxy is rotating. All the stars are moving with the galaxy.
So when you look
at the different stars, it also moves in relation to one another.
So when you look at a star trail and they're going around sort of clockwise or anti-clockwise, you're saying there's other stars within that sort of motion what are going different ways.
It's like if you use a telescope hang on, I'll give you a simple example. If you use a nice telescope looking at Polaris, and Polaris is a three star system. The two other stars you need a telescope to be able to see. But if you observe that over time, then you will see the position between those stars changes.
Okay, yeah, I have I have my overlay now.
Okay,
but the thing is, you're thinking on time. You got to think about the different time scales. On the time scale of just one day, so one night, one star trail, the stars will not have shifted in their their celestial coordinates. It's called right ascension and declination, but we don't have to get into that. The stars haven't shifted in their celestial coordinates, but over 100 years, like I'm showing you here in the live stream or the screen share, so you can see the dark square. I don't know if you see it yet. Yeah. So this dark. Well, actually, first of all, let's talk about the bottom here. I flipped it, but this has 1901 with an 18-inch aperture.
Okay.
So the background image here of the Orion Nebula was taken with an 18-inch telescope, and then mine here was taken with a 5-inch telescope. But if we flip between the two images, specifically this star right here, over the 100 years has shifted a lot.
But what was the original picture taken with a 15-inch?
18-inch.
18-inch, and then you took one with a 19-inch.
5-inch.
5-inch.
Yeah.
Wouldn't it make
and that's the diameter of the mirror?
Mm-hmm. So we can
circle. That make the difference, though. Wouldn't that be responsible for that?
I'm gonna put up Solarium.
Well, no,
except keep in mind, it's only some of the stars. It's only those couple of stars that have moved.
We can circle that one, but if you look at the other ones, they really don't move at all. The only difference is just I wasn't too meticulous. Okay, let's look right here. Let's look exactly right here. So you see these three stars?
Yeah.
Look at how this one right there.
Wow,
in 1901 was almost behind it.
Wait, what time frame is this?
This is from 1901 to 20. This is 1901 to 2022. I think 2022 is when I did this, or 2023.
That's a huge movement. That means that there's something could be rotating around there or something. I don't know.
Well, with this angular resolution, you can't see exoplanets, so these are stars.
And those are stars. Oh, wow.
How many miles away are they?
I don't know. I could not tell you.
Well, but you think to yourself, the movement of that, if that's 60 light years away, imagine the movement on that. When you're talking about, a couple of thousand miles, that's more like a couple of light years of movement.
That's a lot of movement, even for 100 years. And you can, like, maybe if we have more time span,
I think we should build a rocket and fly out and see what's happening.
We can look at this star too. Also had quite a bit of movement.
Not as much as the other one. The other one was like
not as much. So it really does fluctuate. I'm looking for other.
Yeah, that was exactly. Some of the stars move faster relative to the other stars. Yeah,
Mhm.
because they're at grossly different distances.
How many?
I'm gonna-
What? Give me a figure on the distance so I can get my head around it.
Thousands of light years, hundreds of light years.
How many years in a light year? How
A
many miles?
year.
Well, light years a distance, not a time.
Yeah,
Yeah,
that's
a
what I was
light
going to
year.
say.
A light year is 6 trillion miles.
Yeah.
6 trillion miles? Wow.
And Polaris, for instance, is about somewhere around 350 light years away.
Oh, I found another one. Where is it? Yeah, this one right there also moves quite a bit.
No, no.
How
My
long
question,
does it take
my
you?
biggest question on those images that you're representing. Can you like maybe put like a little pathway, like draw a little straight line in between the movements? Can you try and do
Uh,
that?
Put a tangent. Yeah,
I
put a
I
tangent.
probably I probably
No,
could if I like.
this guy knows what I mean. So
Yeah. Let me make the brush a little bit
Well,
smaller.
you could drop a dot on it in one image, and then
there you
flip
go.
the image and draw another dot, and you'll see the two dots side by side.
Mm-hmm.
Was it like here to there, and
There
then
you go.
this one moved here to there. And then another circle here to there.
I think there's,
So
in my opinion, that looks like an orbit. Like there's something orbiting amongst between those stars, but I could be wrong. But that's how I
yeah,
interpret this.
you can see the lines I drew off of it now.
Yeah.
Because
No,
that
I
is
don't.
actually moving. Yeah.
I wonder if I'm not seeing too much down in that corner. This one right here, I think. Yeah, moves like that, but it's more faint, so the line kind of discards it. You can see how
Yeah, it's
in
going left, right.
in 1901 that star was directly in the middle of these two, but then in 2022 you can see that it's off to the side now.
Who's taking these pictures then? Albert Einstein.
Well, this one is mine. The dark square is my own picture,
Was
and
it
then
Albert Einstein?
I don't know where this one was taken. Unfortunately, I just know it was taken with an 18-inch telescope, like it says right there, in September 20th, 1901.
Mad though. Like you got 100 years worth of technology that hasn't really changed much.
That's really amazing, actually.
I think I.
I think
Oh, there you
that's
go. Now it's flipped to how it was. Because this, the picture here is backwards from reality. Weirdly enough.
Well, it's just yeah,
Uh,
it's just which side of the negative you're looking at.
I think I've highlighted most of the really drastically moving stars.
you're not putting a spell on us with
There's a
that.
super faint one right here. Or where'd it go? I just saw it.
Yeah, got it.
Or maybe I was hallucinating that one.
And look there on the left edge, a comet.
Where?
In
I
the
think that's
in the old one,
I think
now
that's just
maybe that's a flaw. Never mind.
yeah, because there's also that there.
Yeah, that's
Coffee.
that's light
Yeah,
leakage or something.
yeah, that's just a weird image artifact.
Because that underlying photo from 1900, that could be like a 10-hour exposure.
It's a black hole.
Yeah. Um. It
Unless
says
there's,
exposure 50 seconds right there.
I stand corrected. Not bad for a 1 minute on film.
Yeah, look. Oh,
Well, this I believe this is a stacked off of a couple of maybe 15-second exposures just cuz my telescope at the time wasn't really good at tracking.
what
Well,
telescope
yeah,
have you got?
and that goes to show that if you had your telescope 100 years ago, you would be Nobel Prize winner.
What's your telescope, by the way?
This was taken with a Celestron Nexstar 5 SE.
Oh, that's what I was looking at the other day. Yeah, I was kind of amazed.
Yeah,
And
so this is
the big money in telescopes is the tracking mount.
and that's the one I have now. I have a tracking telescope, but this winter was just so bitter. I was not able to go out and get the Orion Nebula this year.
Has it already gone to daylight?
It's not gone to daylight, but it's not ideally placed anymore.
Right, Seafoam, could you make that into a GIF, or is that too hard to do?
That's a great piece of presentation right there. I think he's trying to say this could be carried forward.
All right, I have Stellarium pulled up now.
I probably could. It's just this is a pretty big file.
No, it's pretty good. I like that.
Shadow's doing something. You're in what's that? Stellarium.
All right, so I'm gonna put a sidereal day. I have the alt plus the mouse, so you can see the movement of Jupiter. Oh, that's pretty nice. Look at that shit.
Oh yeah.
There's um.
There we go. Yeah, in this picture, the ISS, you can see the solar panels are a little bit more brown than the.
Look back at the image.
When you said
9.78.
9.77, you meant newtons?
Yeah.
They're actually going through, and then like some righteous. Well, people, but if I other people didn't see or didn't get, and you brought it to them, so
Doesn't exist. What I probably did, or what I'm not doing, or the equipment. He goes, "Oh, you can't use a theodolite at those distances. That's not what theodolites are for." Oh, gravity doesn't exist. How can you use gravity to orient an instrument? Because gravity doesn't exist. And so, yeah, it's like at that point, it's like you're right. If you think gravity is not a part of reality, oh, satellites are fake. I'm using GPS. Oh, that's all fake. Oh, it's all tower driven. It's like all kinds of weird stuff where they're asserting that I'm just repeating something, or that's what I've been told, as opposed to something I did. I test things, and they say, no, you're just repeating other people. So when I made the measurements that I presented as measurements, people can go through the math. They never come back with a problem with the math. They just say that, oh, you can't do that.
Also, I want to add to my defense, my own defense. I don't regurgitate what the other people say.
Now,
Just so you know.
now, Shoebill, how many converts do you have?
I don't know, because mostly I support the other people.
What does that mean?
It means I try to enrich the people who can digest the math and the measurements to further their understanding of things like refraction, things like curvature, as measured, how it's measured.
Yeah, but your whole goal though is to basically get people to believe what you believe, right?
Well, that's in part, but I know that there are people like you that there's no point in that. And so the comment you made is like, why am I even here? Well, you're right. You can invite me to leave, and I'll go ahead and leave. But then I was talking to Shadow, and we had a great conversation for a couple of hours.
Well, but this is the thing. So you do understand where you're at, right? Where the majority of the people here don't believe what you believe. So it's literally like if I was to go to a gay bar and tell the gay men to stop being
Okay,
gay. I mean,
you're
I'm
right.
literally
I got
right.
it.
It's like
I
I'm
got it.
wasting my time, right? Like
Yeah,
I
you're
wouldn't
right.
go back. Like I wouldn't go back because I know they wouldn't listen to me. Right? I am wasting my time.
You are correct.
Right?
You are correct. Just now, Gio had a reasonably, interaction with Geo. I had a great interaction with Shadow. Yeah, and you're right. I will leave because you're here. Bye-bye.
Alrighty.
Wait, he just leave. Oh, he said. He said I will leave because you're okay. I didn't hear what he said. I thought he said I believe because you're here. So okay, he said I will leave. All right, he left. I just wanted to figure out what happened.
Yeah. I mean, it is a weird position to be in, right? So like you think you know the truth, and then you're going to come and convert a bunch of people that you never convert.
Yeah, dude, we've brought this up, talked about it extensively. I hear you. If you get into it, some folks will start to feel like you're like psychoanalyzing, but in different ways. But dude, I absolutely like just on a base level, if you get into like psychology, sociology, and this is not really to attack anyone, but what you're describing, like this scenario, it would imply to me, with all due respect to anyone who, and I'm not even talking about Schubel, I'm just saying in general, somebody who is in that position, it would imply to me that it really isn't about that they just want to convert people, because obviously that's not like happening. So then it would imply potentially, with all due respect to that person, that potentially they're in like, if I have to, if I say sort of cognitive dissonance or some kind of a thing where they feel like they need to compel these people, but then it's not really happening. So then it almost seems like it's more maybe about a journey they're on, more than them just coming to correct this group or something, or just to really drop some kind of information that's going to change the course of it. So it would imply that like they're actually in something that they're wrestling with in some way, which I would say the same thing with me. Like if I went to some like knitting group and I was like, knitting's wrong and it's bad and whatever, like it would be the same with me. Like, dude, you got something with knitting, like otherwise just live and let live, let those people do what they do.
Yeah,
Unless you
right.
really, yeah, unless you are like unless you are like converting them and you're doing some, if that's their goal. But if that's not happening, then it's like something else is going on.
Yeah, it's like, what are you really wanting to do? I mean, maybe the thing is that you really want to just start knitting.
No, crocheting's better. You go there to town, crocheting's better than knitting.
Well, it's like the gay bar thing. Although if you relate us to a gay bar, people are going to be like, "Oh, you're calling yourself gay." But yeah, dude, like if just using the analogy though, if someone went to a gay bar all the time, they're like, "I swear to God, I'm not gay," and I'm trying to convince these guys they're not gay. I swear to God, I'm not. But it's like it'd be pretty obvious that it'd be like, either dude, you're gay or you're conflicted with these people. Like you're not really just trying to convert them. There's something more going on. Yeah, just like in that analogy of it.
Yeah, it really just makes no sense.
It's like they're actually trying to convert themselves in a way by trying to get other people kind of.
It's like a weird way to go about it. People are strange. All right.
Yeah, but it's also like the perspective that there's something to this that they can't let go of in some way, which goes back to like the psychology part of things too. Like if you had like proof or validation for something that you thought other people didn't see or didn't get, and you brought it to them so thoroughly that you felt like you were doing, but it's like there's something kind of attracting them to this. It's almost like can't let it go. It's like itching in the back of your mind kind of thing.